writing something in real quick and then I will start. Alright, while I finish this off here, I did already grade your test. I am, pretty happy with the grades, I guess, for the most part. Some of y'all did really fantastic, so that means to me that you guys got Unit 7 pretty decently. So your grades are on Aries in case you're curious. So all grades in Aries are as updated as they can get. I've graded everything inside the box as if it was there. I graded it. It was from 7.8, 7.10, 7.11, 7.12. Your AP Daily Videos, packet for Unit 8, and then your test. So those are the grades that are inside Aries. Okay. All right. Now today is pretty easy. Now we're still going to be using ice tables because, again, when we're dealing with different solutions and concentrations, there's always going to be an ice table of some sort. Now we should be relatively comfortable with an ice table and how it works and how to set it up. So that shouldn't be too much of a difficulty. All right, now, who remembers seeing this in baby chem? You should, because it was taught your baby chemistry year. If you had it with me, you definitely got this. Either your junior year or your senior year, or either you were a sophomore last year or 2 years ago. I did cover this. I didn't need to make that mistake. Scratch off that little part in the back. It's in the back of your thing. All right, now today we are focusing on basically converting between different things using this formula chart. Now, you will be given this formula chart, well, not exactly in the square form, but you will be given the formula chart for acids and bases because you'll be either calculating the H, which is for our acid, OH base, pH, or POH. All right, now it is very simple. We just simply follow the arrows for each one. All right, so let's say we're looking for our concentration of our H, but we're given pH, we just follow the arrow. Here's our formula. The same thing would go if we have pH, we're looking for POH. 14 minus my pH gives me that. We just follow our arrows for each and every one. All right, we should also know that we have acids. Our scale is between 0 to 14. Acids are between 0 and 6, 0 being our strongest acids and 6 being our weakest. Our neutral point is 7. That's when we have equal concentrations of both our hydronium as well as our hydroxide inside of our solution, so it makes it neutral and safe, kind of like how water is. And then we have our bases, which are 8 to 14, 8 being the weakest and 14 being the strongest. All right, so we're going to be using this formula chart to kind of work things through, so it's kind of simple, easy math. I wrote notes over here that I want to write. All right. Now, our acid and base theory focuses a lot on our Bronsted-Lowry. Now, Bronsted-Lowry is very simple. It says that acids are going to donate their hydrogens and bases are going to gain them. So let's say, for example, I gave you a compound and you're like, oh my God, that's an acid. How would I know by looking at that compound that that's an acid? Where? In the front or the back? In the front. We see a compound, its first thing there is an H, we have an acid. All right, cool. I see a compound, oh my God, it's a base. How do I know it's a base? OH in the back. Now, for my Bronsted-Lowry, it says basically that acids are going to lose their hydrogen and become conjugate bases, while bases gain hydrogen and conjugate acids. So we're going to practice more of our conjugate acids and our conjugate bases as we progress further into this one. I believe also in baby chem we identified what was what from our type of reactions as well. All right, so Bronsolori is that our acids are going to give away their hydrogens and our bases are going to take them. Now, anytime an acid loses a hydrogen, it becomes an opposite. It becomes a conjugate base. And anytime that a base gains hydrogen, so it's getting more of it, we increase the hydrogen concentration, so it's going to be an conjugate acid. What's up, Hope? No. Yeah, we're not doing the benchmarks, but I'm not going to change it. It's too late. It's too late. I've been busy doing other stuff. No, I did not. I'm been doing stuff. So I'm kind of busy. I'm talking about acids and bases. Talk to you later. Bye. All right. Okay, so that's the relationship between them all. All right. Now, when it comes to terms of how we write out our acid or our ion for our acid. Now, we have two ways that we can write our acid. We can either write it as H30 or an H. Now, it is the exact same thing. You know, we have hydrogen present, whatever. The way you write it is up to you. Now, AP, though, does prefer to have a symbol for our acid to be H30 instead. Now, if you're to use H, that's fine as well. They accept it anyway, but in collegiate levels, when you do have to take other chemistry classes for whatever it is that you might need to take, H30, which is hydronium, is going to be most accepted. All right, so all in all, our acids are going to lose their hydrogens to become conjugate bases, and our bases are going to gain the hydrogen to become conjugate acids. All right, so we'll focus more into that later. What we're going to play with today is going to be my square. All right. So there's more of the square there. It's obviously in a different order, but point is the same thing. Now, the one thing that you do have to memorize when it comes to acids and bases for your AP test, because they will not give you these at all on your test, is going to be the list of our strong acids and our strong bases. This you have to have in your head going into your test on May 5th. Unit 8 is one of the most highly tested part, besides Unit 3, of the AP Chem test. It's Unit 3 and Unit 8 that have the most questions, the most relevance for. And I will always tell you, anytime an acid and a base is included, it's going to have you determine, is it a weak acid, a weak base, or strong acid, strong base. You're going to have to know our list of them to know that, because it affects a lot of things. When we get into titrations in Unit 3.5, we have to take into account if we have a strong acid or a strong base, so we know what's the titrant and what's our analyte. All right, now our strong acids are hydrogen chloride, hydrogen bromide, hydrogen iodine, with our nitrate, sulfate, as well as our chlorate. Now there is a mnemonic phrase for it, of course, and it is so I brought no clean clothes. SO for my sulfate, I for my iodine, BR for my bromine, right? Yeah. NO for my nitrate, Cl for my chlorine, and ClO for my chlorate. And my strong bases. Now, strong bases are metal hydroxides from groups 1 and 2 on the periodic table. You should know where to find groups 1 and 2 on the periodic table. But our stronger ones, basically any there can be, but our strongest ones include anything are base with sodium, rubidium, strontium, barium, calcium, cesium, lithium, and potassium. And their mnemonic is so really strong bases can certainly look pleasing. Tomorrow, I'm going to give you a pop quiz over your strong acids and your strong bases. So make sure that we do memorize them and study them tonight. We'll be using them a lot in this unit, and especially for your AP Chem test on May 5th. All right. So we're going to be using the little circle today to kind of determine exactly everything that we have, and it's real easy and it flows real smoothly. All right. do? It says, what is the molarity of H30 in the following solutions at 25 degrees Celsius? Determine if they are acids or bases. All right, so it wants to know our concentration, our H30. So I'm going to go ahead and flip over here back to this part. Okay. It wants this, and it gives us different variations of it. All right, you can also use this square up here at the top if you'd like to. It's completely up to you. Well, we need this up here. So let's go ahead and see what we got. All right, for my first I do, it gives me a pH of 3.689. All right. So we have this, but we want that. So let's go ahead and follow our arrow. All right, to go from pH to H, what do we do? It says 10 to the negative pH. All right, so my H30 is equal to 10 to my negative pH. So 10 to the negative 3.689. Let's put that in. This is how you do it. Ooh, sorry. 10 caret negative 3.689. My concentration is 2.04 times 10 to negative fourth. It is a concentration, so it is molar. Easy, simple, right? Now, besides wanting to know what the concentration of the hydronium is, it also wants to know if it's an acid or a base. Now, the only way we can determine if we have an acid or a base is based on the pH and nothing else, not the POH, the OH, or the H30. It is the pH that tells us that. All right, so we do have a pH of 3.689. All right, so looking over here at the scale that we have, would this be an acid or a base? We have 3.689. Is that acid or base? Acid. Easy. All right, our next one, it gives us a pOH of 6.410. All right. So we have pOH, but we want our H. All right, let's go ahead and follow through with our arrows here that we need. Let's go from first pOH to pH. All right, we follow it through from the left over to the right. All right, let's go ahead and find my pH first. If we look at my arrows, my pH is 14 minus my pOH, according to this here. So 14 minus 6.410. We get 7.59 as my pH. Great. Okay, cool. I went from my pOH to my pH. Can I get to my H from here? Yes, I can. Let's follow the arrow to go from pH to H. It is 10 to negative pH. So my H30 is equal to 10 to negative pH. So 10 to negative 7.59. We get 2.57 times 10 to the negative 8. Questions, comments, concerns? Easy, right? Now, we are determining if we have an acid or a base. Now we do that based on our pH. We found our pH earlier to be 7.59. Now it's asking if it is an acid or a base. Well, let's take a look at my pH. It's 7.59. Now usually my pH of a neutral is 7. Is this just 7 or is it higher than 7? Higher than 7. So if it's higher than 7, is it an acid or a base? last but certainly not least, we're given our concentration of our hydroxide. Let's go ahead and find my concentration of my hydronium. All right, we have our hydroxide. This is what we need. Let's follow my arrow. Here's my formula. It is 1 times 10 to negative 14 divided by my concentration of OH. Cool, cool. All right, so let's go ahead and take my 1 times 10 to negative 14 divided by my concentration, which is 1.56 times 10 to negative. See, 1 second, comma, negative 14. Divided by 1.56. All right, I get 6.41 times 10 to negative 11 as my concentration. Are we in agreement with my answer? Excellent. Now, again, we also need to know if we have an acid or a base. Now, the only way we can do that is with our pH. Now, we don't have our pH. We had our pOH, and now we have my value for my hydronium, which is my acid ion. All right, so let's take a look back here. From my acid ion, can I find pH? Yes, I can. Here it is. pH is equal to the negative log of my concentration of hydronium. Okay. So pH is equal to the negative log of 6.41 times 10 to negative 11. Negative log of my answer. I'm going to get pH 10. All right, if my pH is 10.19, do I have an acid or a base? Simple, easy to flow math. Questions, comments, concerns? No, right? Now, besides having the easy flow type of math, we are also going to have ice tables into here. Anytime we have anything that deals with concentrations, we are going to have an ice table present. So considering that we're familiar with it now, let's go and try out my WeDo where we happen to have an ice table. All right, it says a solution of weak acid, HA, has a concentration of 0.1000 molar. The pH of the solution is 3.456. All right, first one says go ahead and write a dissociation reaction for everything. Now remember, our dissociation reactions is when we break apart the entire compound. All right, so let's break it apart. We have HA, which is an aqueous form because again, if it's a solution, it's an aqueous. Let's break it down. It is formed with, I'm going to use hydronium. You can also use just H if you want to, but I do want you to get comfortable when you are dealing with an acid. Its ion is H30, hydronium. You can use H is fine. Make sure you have your charge plus. There you go. I broke apart my H and A. Can you do a dissociation reaction and break apart things? You should be able to by now. We've done it a lot. All right, cool. With this, let's go ahead and write our Ka expression. Now, we've already dealt with K a lot in Unit 7. We had Kc, right? Now, we're going to have Ka or Kb. It still stands for my constant. Now, Ka is going to be my acid, and Kb is going to be used for my base. And as we get to working through these, we'll have a lot of the Ka and the Kb. It's just a constant for either the acid or the base, and we have to specify which one it is at all times. All right, we we know any K expression is my products over my reactants. All right, so we have H30 and A at the top, followed by HA. Can you write an equilibrium expression? Yes, you can. We did it a lot. All right, let's go ahead and calculate the concentration of our H3O ion. All right, cool. Looking back at my stuff, we're given a concentration of HA, but it does give us a pH. Now, from my pH, can I find my concentration of my hydronium? Yes, I can. Let's follow the arrow. So you go from pH to H30, it is 10 to negative pH. Okay. So H0 is equal to 10 to negative pH, which is 10 to the negative 3.456. 10 to negative 3.456. I have a 3.50 times 10 to negative 4 molar concentration. Again, everything that we just did is unit 7. Now let's see how we use unit 7 in unit 8. All right, it says to complete the ice diagram to find the Ka for this acid. All right, let's go and set up our ice table. All right, I'm going to go ahead and put my HA at the top. I have H3O. All right, so I've already a few things in my stuff. We need to know what we have initially going in before we can do anything. Now, reflecting back to my question, it did say a solution of weak acid, which is HA, has a concentration of 0.1000 molar. All right, so I know that I have 0.1000 molar of my weak acid. Now, this question does not mention anything that there's any values for our hydronium or even for our acid. All right, the second set of information that we have is that we now have our actual concentration, our change in everything. All right, so we know that my concentration of H30 at the end of my equilibrium happened to be 3.50 times 10 to negative 4. That is my change. All right, so go ahead and let's apply the change first. All right, let's first determine if this is a forward or reverse reaction. Now looking here at my ice table, do I have a reverse or a forward reaction? A little louder? Forward reaction. We know that my reactants are going to be negative and my products are going to be positive. All right, if I know at the end for H30 I have this amount and I started with 0, we know that my change is 3.50 times 10 to negative 4. All right, it'll be the same thing over here. My ratio of A is the same thing as my ratio of my hydronium. So it'll also be 3.50 times 10 to negative 4. All right, now looking over here at my HA. Now we also again have the same ratio. It's a 1-to-1 ratio throughout the entire thing. All right, so if we only have one of these, my change will still also be 3.50 times 10 to negative 4. All right, let's go ahead and fill out what that is. So 0.1000 minus 3.50 to negative 4. I get 0.0996 as my equilibrium. All right, great. We have everything that we need. Now let's go ahead and find my Ka for everything. Now we said that our Ka expression was my hydronium times my A divided by my weak acid. We have all our stuff. Let's go ahead and fill in our blanks. We have 3.50 times 10 to the negative fourth. I'm just gonna square it because it is the same. Divided by 0.09. And I get 1.22 times 10 to the negative 6. Now, everything just flows. This, honestly, you shouldn't even have to think about anymore when doing any of this here. Now, is there anywhere that you got stuck and you're not sure exactly how I use the square, or are you guys fine with the square? You should be fine. All right, so that is what I have for today. All right, again, all your grades from your Unit 7 Part 1 test is on Google Class. Go Aries, it's on Aries. All right, you're more than welcome to look at that. All right, guys, go ahead and do